Welcome to the video lecture for CS8591 Computer Network Unit 4 Transport Layer Video 2. The next problem is what value is sent for checksum in each one of the following hypothetical situations. First one, the sender decides not to include the checksum. So what to do now? The value sent for checksum field is all zeros to show that checksum is not calculated, right? Second one, the sender decide to include checksum, but the value of the sum is all ones. When the sender completes the sum, the result is all zeros. The sender complements the result again before sending. The value sent for checksum is all ones. The second complement operation is needed to avoid confusion with the case in part A. Third one, the sender decides to include checksum, but the value of the sum is all zeros. In this situation, it never happens because it implies that value of every term included in the calculation of the sum is all zeros, which is impossible. Some fields in the pseudo header have non-zero values. Shall we go to the next problem? Right? So, what happens when a packet is lost? So, we will see the diagram, flow diagram. We have transcender, transport layer, receiver, transport layer, right? And here we are having the timer. So, before sending, we have to start the timer. So, this is our window, right? Sliding window in the sender side, and this is the sliding window in the receiver side. So, the window size here is 7 and the window size here is 1, right? So, now the packets 0, 1 and 2, 1, 2 and 3 are sent, right? So, first we will send the packet 0. We started the timer and the slided and the window is slided and the packet 0 is sent. It successfully arrived at the receiver and we received the acknowledgement. So, it is also acknowledged, acknowledgement is also arrived. So, it is a successful transmission. Now, the timer stops, right? Then the second case, we will start the timer. This is case 2. We will send the packet 1, right? The packet is lost, right? It doesn't arrive at the receiver, right? And before the timeout, it sends the second packet. For that also we received acknowledgement 1 and packet 3 is also sent and the packet for acknowledgement 1 is arrived for the packet 3. So, here the packet is also discarded and the acknowledgement is also discarded because packet 1 is lost. So, after the timeout, the entire process is stopped and again we are sending the all 3 packets, packet 1, packet 2 and packet 3. So, we have to send packet 1, packet is arrived and acknowledgement 2 is arrived. Packet 2 is sent and acknowledgement 3 is arrived. And packet 3 is sent and acknowledgement 4 is arrived. So, the receiver receives packet 2 and 3, but they are discarded and because they are received out of order. The receiver expects packet 1, but here it receives packet 2 and 3. So, it sends the acknowledgement 1 to show that it expects to receive packet 1. It indicates the sender that I expect packet 1. However, these acknowledgements are not useful for the sender because the acknowledgement number is equal to SF and not greater than SF. So, the sender discards them, the packet 2 and 3, and the timeout occurs, the sender resends the packets 1, 2 and 3 which are acknowledged, right. So, we will go to the next problem, right. Last one. If the data length is 16 bytes, calculate the efficiency of the transmission in TCP. So, the data are 16 bytes. So, the length of the header, no options, it is 20 bytes. So, the ratio is 16 by 20 plus 16, that is 4 by 9. This is the efficiency of the transmission in TCP. Thank you.